All right, so now let's take a look at this logarithmic equation. So we have two different logarithms on the left side, and we have a constant on the right. Now, what we have to pay attention to is the fact that we can't fly the plane yet. Now, you may be thinking, oh, why not? We've got log base 3, 3 to the second. Well, not quite. What we have to do first is that we have to take these two logarithms that are over here, and we need to combine them into a single logarithm using one of those properties of logs. And so having the sum of these two logarithms with the same base means that we have a single logarithm of the product of those guys. And then, of course, this is equal to 2. So now we can talk about flying the plane, where we take 3 to the second power is equal to the stuff that's on the inside. Now, just for making things a little bit easier for us for later on, I'm going to put that 3 to the second on the right side. And I'm going to put the rest of the stuff here on the left. So the x plus 3 times x minus 5. So on the right, of course, we just have 9. On the left, if you FOIL this out, you would get x squared minus 2x minus 15. So we got rid of the logs, and now we have something that's quadratic, so we solve it as we would solve any other quadratic. So let's move the 9 to the other side. That way we have all of our terms for the quadratic equation on the same side. So x squared minus 2x, this becomes minus 24 is equal to 0. Now the progression that we have for solving a quadratic equation is we first try to see if we can use the square root property. But since I have x in two different spots right here, I can't use the square root property. So then I try to factor. And this is something that factors. And it factors as x minus 6 times x plus 4. Remember, this is still equal to 0 because you have an equation. And when I solve this, I get x equals positive 6 or x equals negative 4. Now, before you box both of these or you try to put them both into MyMathLab, come back up here to the original statement. In this original statement, we have to make sure that we don't end up with anything that's undefined. So from that first inequality, or from that first logarithm, we know that x plus 3 has to be greater than 0. And from the second inequality, or second logarithm, we're jumping ahead to inequality, x minus 5 has to be greater than 0. So when you solve these, you find out that x has to be greater than negative 3, and x has to be greater than 5. So if you look at this and you remember that and means intersection, you're going to find out that the only place that we can have answers, the only place we could even plug in numbers into the original expression is going to be with this intersection, which ends up being just x is greater than 5. So if we look at our answers, there's only one answer here that is greater than 5, and that's x is equal to 6. So this other one, x equals negative 4, is going to be extraneous. Okay, and it's not that we did anything wrong. It's just the way that the original problem was written. Now, I want you to compare this one to the next problem that we have. So this next one says log base 2 of 5x squared plus 2x is equal to 4. All right, so let's fly the plane because we already have a single logarithm on one side. 2 to the 4th is equal to this, so let's write it like this. So 2 to the 4th on the right, and 5x squared plus 2x on the left. Of course, we work this out. Keep in mind that 2 to the 4th is 16, and let's go ahead and move that to the other side, so it's going to be minus 16. Now, if you find that you are making careless mistakes by raising to the 4th power and moving to the other side at the same time, do it one piece at a time. Okay. Remember, 2 to the 4th is 16, and then we subtract 16 to move it over to the left. Then we need to factor this. Okay. So this is something you should be able to take care of out on the side. When I factor this, 5x squared has to break down as 5x times x. And the factors for 16, I'll end up using 2 and 8. the 2 here and the 8 here. Let's see, we do a +2 and a -8. And again, just kind of checking off to the side to make sure we're on the right track. On the inside here is a -8x. On the outside is a plus 10x. So that does give me the positive 2x term that I have in the middle. Okay. Now to finish solving this, you set each of these factors equal to 0, and you solve. So it means x is going to equal positive 8/5, or x is equal to -2. Now from the previous example, you may be thinking, okay, well, the positive one is the one that works, and the negative one I have to discard. Well, not entirely. Because see, what's going on here is that you need the expression 5x squared plus 2x to be greater than 0. If you factor this, you have x times 5x plus 2 is greater than 0. And this ends up giving you an interval from -infinity to -2/5 union 0 to infinity. So any solution that we have to this for this equation has to satisfy this restriction of the domain found from that original logarithmic expression. If we look at our answers, both 8/5 and -2 fall within this domain. 8/5 is of course over here in this part from 0 to infinity, and -2 falls into the left side. So what's the difference? In the first problem, we had 2 individual logarithms, and the domain for the whole expression was going to be limited by the x is greater than 5. Because if you're greater than -3, you're not necessarily greater than 5. But when you're greater than 5, you're greater than -3, so that satisfies both of those. Now, if the equation had started right here, then we would have been able to include -4 as the solution, because you would plug in -4 and take care of evaluating the expression inside before you do the logarithm. And if you do that, you end up with a positive number before you take the log. As the original problem is written, if I plug a -4 in up here and here, you end up trying to take log of -1 and log of -9. But we can't do that. It doesn't satisfy the domain for those logarithmic expressions. But down here, because we have something that's quadratic, already inside that in the original form, both of these answers are going to work. Pretty cool, huh?